So this video is going to show you what fire is. Now I feel like when I go to school and think about what we teach in chemistry class, that it's insane that we ever go through without ever talking about what is this? Like, what is going on in this flame here that's causing this light to come off in the particular way that I've done. So to emphasize this a little bit, I'm running my methane through a boric acid ethanol solution, which is causing me to get this green flame. And also, I'm sure many of you have done this in your chemistry class, but you can add salts to this and the flame will change color. So this is a lithium salt, and when I add that to it, I get a very, very distinct, sharp red color that adds to the flame. But the question is never answered, what is this flame? What is fire? What is going on? Now some people will sit there and talk about chemical reactions and say, okay, there's a combustion reaction. But I want to go through the question of, what actually is this? I can pass my finger through it, although I wouldn't for the Bunsen burner, but if I let a match, you've seen someone run their finger through it. So what is here that's giving off this light? What is causing this light to happen in a very detailed fashion? Okay. So when I was in college, I took a class in physics, and we did an experiment, and I got to see, in my head, very clearly, what causes light. Now, in order to know what causes light, you need to start with electrons. So traditionally speaking, electrons and atoms can move between energy states. And when they drop back down, they give off a particular color of light based on how big the drop is. So a violet light might be given off for a large drop. A slightly smaller drop might give you off green light or red light. Okay? So light occurs when these electrons are accelerating and when they're moving down from an energy level to another. The experiment that I saw that made me understand what light was very simple. We had an electroscope which looks like this. And we would charge the electroscope. So I'm adding negative charge to this PVC pipe. When I bring it nearby, it pushes electrons down into this two veins down here. So when I touch one, those electrons have now come to me down through the ground. So this now has a positive charge. Because of that positive charge, this part repels this part. So the key thing for me for understanding what it was that fire was we took a charged electroscope and we took fire. And when we brought it nearby, that charge somehow disappeared. Okay. And that to me makes perfect sense as to what the light is coming from, what's happening in the flame. The actual process of what's happening is you have a chemical reaction happening where you're breaking bonds and you're making new bonds. And as you make the new bonds, there is a lot of force involved in a bonding scheme. And so when you're making the carbon dioxide and you're making the water molecules, those pieces are coming together with a lot of force which can cause them to accelerate, and leaves you with a product that's going to have moving at a larger velocity, or in other words, we would call it hot. Okay? Because these things are moving so quickly, what happens is as they collide with things that are around them, they're able to strip off an electron. And when that electron goes back down to the ground state that it began with, it gives off the light. So the light you're seeing in here is from air molecules being ionized, and electrons coming back down on air molecules that had previously been ionized. The proof for that, or the evidence for that, is that if you take the same experiment that we did before and we charge up our electroscope, okay, so we make this positively charged like before, and we hold a screen between the fire and between the electroscope, those ions that we were seeing discharge the electroscope before now don't have the same effect as they did. Okay, if I remove the screen and bring this close, you can see that clearly that's going away. But with the screen in the way, that's able to absorb and block those ions from being able to reach this point where that charge would then become neutralized. So what fire is what the flame of the fire is a byproduct of the reaction where the electrons are being able to be stripped from certain parts of the air and whatever else is in this. Okay, when I add the salt to it, that is capable of having its electrons moved around and stripped and then drawn back down to them. And so that process of the electrons falling down as a result of that chemical reaction is what gives you the light. And that's why you can run your finger through a piece of flame, or in this case I'm running the screen through the piece of flame, because it's just air in there. It's ionized air, it's a plasma, but it's just air. So there's not anything tangible there, but I'm still able to get the light from it.